Hello everyone, welcome to my YouTube channel. And currently we are doing our top interview question series. And today we are going to do a next question, which is H index. So the question says that we have given a array of integer citizens citations, where citations I is the number of citations a researchers received for their ith paper, and we have to return the researcher's H index. So in this question, what we have given a citations array, which is indicating the citations which a paper of a researcher has received. So in here you can see the first paper has received 3 citations, second paper of this researcher has received 0 citations. So this is the array which we have been given. Now from this we have to find the researcher's H index. And according to the definition, the H index is defined as the given researcher has published at least H papers that have been cited at least H times. So this is the definition of H according to a Wikipedia. So in first example, to understand what is H, you can see the output is 3, and this is because that we have cited at least 3 positions or 3 papers which have the citations greater than 3 or equals to 3. So if we find this value, then we will return it. So in every question we have to check for it, that we have to check that there must be at least 3 paper at there must be at least H papers which have values greater than or equals to H. So we return that H. So in this question, we are going to solve by two approaches. First is linear, and second is going to be our binary. We are going to apply linear search and binary search. So the first approach is linear. So let's understand how we are going to do in this. So first we are going to sort this citations array. So in sorting, we are sorted in descending order, and now we are going to take a value h which is equals to 0, and we are going to start iterate over this sorted array. So in first iteration, what happened, when we are at first position, we are going to check that if its value is greater than or equals to first, because we have first visited our first paper. So if its value is greater than or equals to 1, that means we have to increase our h. That means we our minimum value of h is going to be 1. It is fixed. Now when we move to the second index, and here we have already covered 2 papers, so if this value is greater than 2, then we are going to increase our edge. So that's how we are going to do. And one point to notice that we have already arranged it in descending order. So if the second one is greater than 2, that means definitely the first one is greater than 2. So it always going to be satisfied. So for like this, we are going to move to the third position, and at third position you can see that the value is equal, so it is also going to increase. So our h is going to be 3 by this position, which is third. Now when it's moved to the fourth position, which is 1, now you can see that it is less. So in this condition, what we are going to do, we are going to break our loop, and we are going to return the edge. So this is the simple approach. Now let's code this. So what we have decided to take a value h equals to 0, and now we are going to sort it. So we are going to sort citations dot, we are going to reverse it. We are going to sort in reverse order. So we are going to use r begin and r end. Citations dot r end. Okay, now we are going to run a for loop from int I equals to 0, I less than citations dot size I plus plus. Now we have to check that if our citations value at I index, or now we have to check our citations value at I index. If it is greater than or equals to I plus 1, then what we have decided, we are going to increase our h, and else we are going to break. Okay, so this is the overall code. Now we are going to return the value of h. So it is successfully accepted. Now let's submit and check if it's all correct. Okay, so it is running fine. Now let's move to our second approach. So now let's see the second approach, which is binary search solution. And in here what we have to do, so in here first we have to first sort our array, and we have to arrange our binary search. In here we have to set two pointers, which is left and right, which is start and end pointers, and we have to execute the binary search. And the condition is going to be three conditions. First, if our citations mid is equals to n minus mid, where n is the length of the array, so if it is equal, that means the value h we have achieved, that means there is no maximum value or minimum value possible, it is the final value, so we have to directly return. And when we get that our citations mid is less than n minus mid, then what we have to do, we have to increase our start index to mid plus 1, because here the value of citations mid value is less, that means we can get more values or higher value of h. Now when our citations mid is greater than n minus mid, that means that our h is already high, we have to check before it, so we have to decrease our h. So now let's try to code this. So as we have to take two pointers, so first let's take n, which is the going to be our size, and let's take is citations dot size. Okay, now let's we are going to take the two pointer in the start equals to 0 and end equals to n minus 1. Now we have to sort this array. So for sorting, we are going to sort dot begin. Okay, citations dot begin, comma citations dot end. So now we have sorted. Now we have to do the binary search. So in binary search, we are going to run a while loop in which we are checking that unless our s is less than n equals to v, we are going to run it. Now we have to first calculate our mid. So our mid is going to be start plus end minus start by 2. And now we have to check for three conditions. First condition is going to be when our citation mid is equals to n minus mid. So what we have to do, we have to return n minus mid. Now else if our citations mid is less than n minus mid, then what we have to do, we have to increase our start to mid plus 1. Okay, now else part, in which when our citations mid is greater, so we have to decrease our end to mid minus 1. Okay, now finally after completing a while loop, we are going to return n minus start. Okay, so this is the binary search algorithm. So here is a problem. Okay, so it is end. Now let's try to rerun. Okay, so it is accepted. Now let's submit it to check if it is working fine or not. So it is successfully submitted. So this is the question for today. So thank you all.